There are places on Earth that were never meant to become destinations. They do not exist to be visited, photographed, or conquered. They exist as boundaries, natural limits, where human presence fades and the planet resumes its own rhythm. These landscapes are not hidden by accident. They remain unseen because distance, terrain, climate, and time actively resist intrusion. Across deep forests, isolated mountains, frozen coastlines, and fractured deserts, entire systems continue to operate beyond human scale. Rock erodes at rates measured in millimeters per century. Ice records atmospheres older than civilization itself. Water falls, evaporates, freezes, and returns without regard for observers. In these places, nature does not perform. It simply continues. This world is not defined by landmarks or popularity, but by thresholds. Each location follows its own internal logic, geological, biological, or climatic, that limits how close humans can come. Some allow brief contact, others impose rules through altitude, toxicity, pressure, or isolation. And some remain effectively unreachable, not because they are forbidden, but because they function outside human tolerance. What makes these places extraordinary is not just their appearance, but their independence. They evolve without correction. They endure without documentation. Their beauty is not enhanced by attention, and their absence of crowds is not a flaw. It is proof of integrity. These environments remain intact precisely because they resist assimilation into the human world. This journey does not move from famous to obscure. It moves along a gradient of access, from landscapes where humans can still walk, swim, and stand freely, toward environments that slowly withdraw permission, where presence becomes conditional, then restricted, and finally irrelevant. Each place revealed here represents a different boundary, a point where scale overwhelms the body, where silence replaces familiarity, where time stretches far beyond memory. Together, they form an impossible world, not imaginary, not distant, but real, existing alongside us while remaining fundamentally separate. This is not a search for destinations. It is an exploration of limits. Wave rock rises from the dry plains of Western Australia as a contradiction in stone. In a landscape defined by flat horizons and muted motion, A single granite wall curves upward like a breaking ocean wave, suspended at the exact moment before collapse. The formation stands approximately 49 feet high and stretches nearly 360 feet in length, its surface bending with a precision that appears deliberate, almost sculpted, yet no human hand shaped it. This structure is not the result of sudden force or violent upheaval. Wave rock formed through patience. Over an estimated 2.7 billion years, chemical weathering and erosion worked slowly across a massive granite outcrop. Rainwater seeped into microscopic cracks, dissolving minerals along the rock face. Gravity carried moisture downward, concentrating erosion at the base. Wind polished exposed surfaces. Heat expanded the stone by day and contracted it by night. What remained was not chaos, but curvature. The wave's smooth face is marked by long vertical streaks in shades of brown, yellow, and black. These bands are created by mineral runoff, iron oxides, and carbonates deposited over immense spans of time. Unlike sedimentary layers, they do not record sequential buildup. Instead, they trace the movement of water across the rock, turning the surface into a map of invisible flows. The colors change subtly with light and shadow, giving the stone a sense of motion, even while it stands completely still. From a distance, the formation appears almost light, as if the rock were thinner than it is. Up close, scale reasserts itself. The granite wall is dense, immovable, and cool to the touch. Standing at its base, human proportions feel abruptly reduced. The curve towers overhead, blocking the sky, enclosing space the way a wave would moments before breaking. Yet there is no sound, no spray, only silence and mass. Wave rock exists at the edge of human accessibility. It is neither remote nor hostile. Roads reach it. Visitors can walk along its base and climb to the flat summit above. And yet, despite this access, the formation resists domestication. It cannot be reframed as entertainment or spectacle. There is nothing to conquer, no route to master, no summit that offers victory. The experience is static, contemplative, and humbling. Culturally, The rock carries meaning far older than modern geography. For indigenous Australian communities, the formation is linked to the rainbow serpent, a creator being associated with water, land, and life. In this context, the wave is not frozen. It is eternal, existing outside linear time, embodying a force that shaped the land and continues to inhabit it. The smooth curve becomes not an object, but a presence. What makes wave rock remarkable is not rarity or danger, but restraint. It demonstrates how dramatic form can emerge without violence, and how the planet's most striking shapes are often the product of quiet repetition rather than catastrophe. The wave does not announce itself. It waits. As an opening point in this journey, wave rock represents the last place where the Earth still allows easy approach. Humans can stand here without permission, without preparation, without consequence. And yet, even at this level of access, the formation establishes a boundary. It reminds the observer that beauty does not require interaction, and that the land does not exist to respond. This is the moment where the journey begins to turn. From here forward, landscapes will withdraw tolerance, access will narrow, rules will appear. Wave rock stands at the threshold, a place where the planet first reveals that it can astonish without yielding control. Giola Lagoon lies carved into the rocky coastline of Thasos, only a few steps from the open Aegean Sea, yet it behaves as if the ocean does not fully exist. From above, it appears as a natural basin of stone, an oval cavity sculpted directly into limestone, filled with intensely blue water and sealed on all sides except for a narrow, invisible connection to the sea below. The lagoon formed over thousands of years as waves repeatedly struck a weaker section of coastal rock. Rather than collapsing the surface entirely, erosion hollowed the limestone inward, creating a contained pool perched just above sea level. What remains is a rare balance, a body of seawater that is technically part of the ocean, yet functionally isolated from it. The walls of Giola rise between 15 and 23 feet, smooth and pale, reflecting sunlight downward into the water. This reflection amplifies color. Under direct sun, the lagoon shifts from light turquoise to deep cobalt, depending on angle and depth. The clarity is striking. Standing at the edge, the bottom is visible through several meters of water, revealing layered stone shaped by long-term marine abrasion. Despite its proximity to the open sea, Giola remains unusually calm. Offshore waves can reach heights of 6 to 10 feet, yet inside the pool, the surface often stays almost perfectly still. Only during stronger swells does the lagoon respond. Seawater pushes upward through hidden channels in the rock, lifting the water level by several inches, sometimes close to a foot. The effect is subtle but unmistakable. The pool seems to rise on its own, as if breathing with the sea beneath it. This movement defines the lagoon's character. Giola is not static, but it is controlled. Energy enters slowly, diffused through stone, stripped of violence. The surrounding rock acts as a filter, allowing water through while removing force. As a result, the lagoon becomes a place where raw marine power is present yet restrained. For those standing at the rim, the experience is defined by contrast. To one side, the Aegean moves endlessly, wind-driven, unpredictable, loud. To the other, the lagoon holds silence. The sound of waves fades. The body senses exposure, yet the water below appears safe, contained, almost domestic. This tension creates a rare psychological boundary, the feeling of standing between chaos and order. Giola remains accessible, but not effortless. Reaching it requires crossing uneven rock under direct sun. There are no structures, no guardrails, no designed entry points. The landscape offers no accommodation. Visitors adapt to the stone, not the other way around. Even here, at this early stage of the journey, the environment sets the terms. Culturally, locals have long viewed Giola as a place of quiet refuge, a natural basin where the sea rests. Unlike sacred mountains or forbidden zones, its significance is subtle. It is not marked by ritual, but by behavior. People lower their voices, movement slow. The space encourages restraint. Giolla Lagoon represents one of the final environments where the Earth still allows casual presence while maintaining control. Humans may swim here, they may linger, but the setting makes clear that calm is conditional. The stone decides how much of the sea is allowed through. In the logic of this journey, Giolla marks a transition. It shows how nature can contain immense power without displaying it, and how beauty often exists not in extremes, but in balance. From this point forward, balance will begin to fail. Landscapes will grow less forgiving, boundaries will harden. Here, the sea pauses, but only briefly. Umphuston sinkhole opens suddenly in the limestone plains of South Australia, a circular void where the ground has given way to gravity and time. From the surface, it appears as an abrupt interruption, an open shaft, roughly 66 feet deep and about 164 feet wide, its walls dropping vertically into a green, enclosed space below. Unlike most dramatic landforms, it does not rise to be seen. It reveals itself by absence. The sinkhole began as an underground limestone cave, slowly carved by water over thousands of years. Rainwater, slightly acidic, seeped through soil and fractures, dissolving calcium carbonate and widening hidden chambers beneath the surface. As the ceiling thinned, it eventually lost structural integrity and collapsed inward. What remained was not a cavern, but an opening, a geological wound exposed to the sky. Left alone, such formations often become unstable, barren, or inaccessible. Umphuston took a different path. In 1886, landowner James Umphuston recognized the potential of the cavity and began an unusual intervention. Soil was added, terraces were carved into the rock walls, trees and ferns were planted. Over time, the sinkhole transformed into a sunken garden, carefully balanced within the rigid geometry of limestone. This transformation did not erase the geology. The rock walls remained dominant, curving inward and enclosing the space like a natural amphitheater. The diameter frames the sky above, while the depth isolates the floor below from surrounding winds. As a result, the sinkhole developed its own microclimate. Air settles, moisture lingers. Temperatures remain more stable than on the surface, allowing vegetation to thrive where the surrounding plains stay comparatively dry. Standing at the rim, perspective shifts abruptly. The open ground gives way to depth, sound drops, movement below feels distant, as if observed through a vertical lens. Descending into the sinkhole reinforces this separation. Each step lowers the body away from the horizon and into a contained world where scale is defined by walls rather than distance. The garden itself is not ornamental in the conventional sense. It follows the structure imposed by geology. Plants grow where moisture collects. Roots cling to rock. Light enters from above, filtered by the circular opening. The design is adaptive, not decorative. Human order exists, but it bends to the form of the collapse. In the mid-20th century, neglect nearly reversed this transformation. By the 1970 seconds, the sinkhole had fallen into disuse and was used as a dumping ground. Restoration efforts eventually cleared the site and re-established its value, not only as a botanical space, but as an example of how geological damage can be reinterpreted rather than erased. Umfeston's sinkhole occupies a rare position in the landscape of this journey. It is a place where human intervention did not overpower nature, but negotiated with it. The collapse remains visible. The void is still the defining feature. Yet life has been reintroduced without denying the origin of the space. This balance makes the sinkhole distinct from the environments that follow. Here, the earth allowed alteration. It permitted care. The boundary between human and landscape softened rather than hardened. But the lesson is subtle. The sinkhole's success depends on restraint. It works because it accepts limits imposed by stone, gravity, and water. As a waypoint in this exploration, Umpherston marks the final moment where nature still accommodates repair. Beyond this point, landscapes will no longer adapt to human intention. They will resist it. Here, collapse did not end a system. It reshaped it. Ball's Pyramid rises from the Pacific Ocean as a singular act of defiance against access. A narrow volcanic spire, it stands approximately 1,844 feet high and less than 1,000 feet wide, lifting almost vertically from the sea, with no shoreline, no beach, and no gradual approach. From a distance, it resembles a shard of stone, driven upward through the surface of the earth, sharp, exposed, and uncompromising. Geologically, Ball's Pyramid is the eroded remnant of an ancient shield volcano that formed nearly 7 million years ago on the Lord Howe Rise. What remains is not a mountain, but the hardened core of a system, long stripped away by waves, wind, and salt. Softer materials collapsed and vanished. Only the densest basalt endured. The result is a structure with almost no flat surfaces, no soil accumulation, and no natural pathways for ascent. The ocean surrounding the spire is deep and restless. Swells strike the rock directly, rebounding into turbulent currents that make approach by boat difficult even in calm weather. There is no protected anchorage. The sea itself functions as the first barrier. Above it, gravity completes the exclusion. The walls rise steeply, fractured and unstable, shedding rock under constant erosion. For decades, Ball's Pyramid was treated as an extreme challenge rather than a forbidden place. In the mid-20th century, a small number of climbers attempted ascents, navigating loose rock and unpredictable conditions. The danger was constant. Routes shifted, holds failed. Rescue was nearly impossible. Eventually, access was halted. From the 1980 seconds through the early 2000s, climbing was fully banned, and even after partial reopening, entry was restricted to rare, tightly controlled permits. This restriction transformed the pyramid's role. It ceased to be a test of human endurance and became a protected isolate, an environment where exclusion was not symbolic, but enforced. Today, mass tourism is impossible. Only approved scientific teams are allowed to land, and even then, presence is temporary and minimal. The reason for this protection lies not only in danger, but in rarity. In 2001, scientists made an unexpected discovery within a single crevice near the summit. A population of Dryococcelus australis, the Lord Howe Island stick insect, a species believed extinct for more than 80 years. Surviving on one shrub, in one fissure, the insects had persisted only because isolation made intrusion unlikely. Ball's pyramid functioned as a biological vault. This discovery reframed the spire as more than a geological curiosity. It became proof that inaccessibility preserves the same features that repel humans: sheer walls, exposure, isolation, also create refuge. Evolution continued here without disturbance, hidden in plain sight. Visually, Ball's pyramid is stark. Its surface is dark, angular, and stripped of ornament. There is no vegetation to soften its outline, no gradual transition between sea and sky. At dawn and dusk, the spire casts a long, narrow shadow across the water, emphasizing its scale and solitude. The human eye searches for detail and finds none. The structure offers no invitation. Within the logic of this journey, Ball's pyramid marks a critical shift. This is no longer a place where humans negotiate access through effort or adaptation. Permission has been removed entirely. The environment does not challenge the body, it excludes it. Here, the boundary is absolute. The earth does not ask for restraint, it enforces it. Sviazhsk sits at the confluence of two great rivers, rising gently from the water as an island that seems detached, not by distance, but by rhythm. From afar, its silhouette appears compact and deliberate. A cluster of wooden churches, sloped roofs, and pale walls gathered tightly together, surrounded on all sides by open water and sky. There is no gradual transition into the town. One crosses a narrow causeway and time immediately slows. Founded in 1551, Sviazk was constructed with extraordinary speed. Entire buildings were prefabricated upstream, dismantled, transported by river, and reassembled on this isolated hill in less than a month. The result was not a temporary outpost, but a complete settlement, functional, fortified, and self-contained from its first days. That original logic of isolation still defines the island today. The ground beneath Sviazk plays a crucial role in its survival. Thick layers of sediment and clay stabilize wooden foundations, allowing structures to endure centuries of seasonal freezing, thawing, and humidity. Many buildings here are more than 450 years old, assembled without metal nails. Traditional joinery allows the timber to expand and contract naturally, preventing fractures that would destroy less adaptive architecture. Climate reinforces the island's separation. Humidity levels often hover between 65 and 85%, especially in the early morning, when dense fog drifts across the water and wraps the shoreline. At these moments, the town appears to float, edges dissolve, the horizon disappears. Sviazk becomes visually disconnected from the mainland, suspended in a narrow band between river and sky. Sound behaves differently here. Water absorbs noise, wind carries it away. With limited vehicle access and predominantly pedestrian movement, the island maintains an unusual quiet. Footsteps echo softly against wood and stone. Church bells travel farther than expected, lingering over the water before fading. The absence of modern rhythm traffic, machinery, crowds creates a perceptual gap that feels deeper than geography alone. In winter, isolation intensifies. Snow and ice transform the rivers into white plains, and Sviajsk appears as a solid block of architecture embedded in frozen silence. In summer, reflections turn the water into a mirror, doubling rooftops and towers and blurring the boundary between structure and environment. In every season, the town resists urgency. Sviajsk has never been truly remote in distance, but it has always been remote in function. Its island position made it ideal for control, observation, and containment. During the 20th century, this same isolation led to darker chapters, when religious buildings were repurposed and the town became a site of confinement. Later, restoration returned Sviajsk to preservation rather than occupation, reinforcing its role as a place to observe rather than inhabit intensively. Today, visitors often describe the experience as stepping into a preserved layer of time rather than a living city. Movement slows naturally, attention shifts to texture, light, and spacing. The town does not demand exploration. It invites stillness. Within the structure of this journey, Sviajsk represents a subtle but important boundary. Unlike the geological extremes that surround it, the island does not exclude humans through danger or scale. Instead, it withdraws through atmosphere. It disconnects by quiet, by fog, by the absence of modern acceleration. Here, the boundary is temporal. Sviajsk shows how isolation can exist not in miles, but in pace, and how stepping away from time can be as disorienting as stepping away from the world itself. Peninsula Valdez extends into the South Atlantic as a broad, pale landform, defined less by features than by absence. At first glance, the terrain appears almost unfinished, low, flat, and sparsely vegetated, bordered by cliffs that drop into cold, dark water. There are no dramatic peaks or dense forests to draw attention. Instead, the peninsula's power comes from scale, exposure, and relentless wind. Geologically, Valdez rests on a sedimentary platform, formed approximately 15 million years ago, when shifting sea levels alternately submerged and exposed the region. Long horizontal bands of rock record this transition, revealing ancient shorelines and marine deposits now lifted above the present ocean. The land itself receives little rainfall, on average only about 7 inches per year, leaving the surface dry, compacted, and largely unchanged by vegetation. What defines the peninsula most strongly is wind. Coastal gusts frequently reach speeds of more than 50 miles per hour, sweeping across the open plateau with no obstacles to slow them. Fine layers of sand and dust are lifted just inches above the ground, drifting sideways in continuous motion. From a distance, the surface seems to move. The land does not feel solid. It feels active, restless, shaped moment by air rather than water. Beyond the cliffs, the sea drops quickly into deep basins, exceeding 650 feet. These depths allow cold, nutrient-rich currents to rise toward the surface, supporting one of the most productive marine ecosystems in the southern hemisphere. Whales, seals, sea lions, and migratory birds rely on these waters seasonally, turning the surrounding ocean into a dense web of life that contrasts sharply with the barren land above. This juxtaposition is central to the peninsula's character. On land, resources are scarce. On sea, abundance gathers invisibly below the surface. Standing near the edge, one looks out over water that appears empty, unaware of the biological concentration moving beneath. The environment withholds spectacle until the moment it chooses to reveal it. Human presence here is limited, not by prohibition, but by discomfort. The wind erodes patience. The distances exhaust attention. Roads stretch across open ground with few reference points, making navigation feel uncertain despite clear visibility. Shelter is minimal. The landscape offers no sense of enclosure, no relief from exposure. Over time, this openness becomes psychologically demanding. Sound behaves differently under these conditions. Wind dominates, flattening other noise and creating a constant low roar. Voices are carried away. Silence is never complete, yet communication feels diminished. The body remains aware of itself, of balance, of temperature. There is no place to disappear into distraction. Despite this severity, Peninsula Valdez is one of the most carefully protected regions in Patagonia. Its designation as a wildlife sanctuary restricts development and preserves the fragile interface between land and sea. Access is managed, not to create exclusivity, but to maintain ecological function. The peninsula is valuable precisely because it remains difficult. Within the progression of this journey, Valdez represents a turning point. This is no longer a landscape shaped for contemplation alone. It actively wears down human presence. The boundary here is enforced through exposure rather than danger, through wind that never stops and distances that refuse compression. Peninsula Valdez does not intimidate with height or depth. It empties the frame, and in that emptiness, it reveals how scale and isolation can quietly assert dominance, leaving humans present but never comfortable. Mount Fanjing rises above the forests of Guizhou as a landscape divided vertically. Below, dense woodland absorbs sound and light. Above, isolated stone pillars break free from the mountain mass, standing like markers suspended between earth and sky. At an elevation exceeding 8,400 feet, the summit exists in a zone where terrain, atmosphere, and perception begin to separate. Geologically, Mount Fanjing is an anomaly. While much of the surrounding region is composed of relatively young formations, the mountain preserves ancient metamorphic rock that has remained largely unchanged for hundreds of millions of years. Tectonic uplift raised this resistant core, while softer materials eroded away, leaving behind steep faces and narrow summits that appear detached from the slopes below. The result is not a single peak, but a set of isolated stone structures emerging from a sea of trees and mist. The most striking feature is the twin pillar formation at the summit, where sheer rock columns rise abruptly, connected only by a narrow ridge and a man-made walkway. From a distance, these pillars appear to float. Clouds roll in beneath them, masking the forest and erasing all reference points. Depth collapses. The mountain no longer feels grounded. It feels suspended. This effect is not constant, but cyclical. Multi-layered cloud systems move rapidly across the summit, alternately revealing and concealing the stone. In moments of clearing, the landscape snaps back into scale. Seconds later, it dissolves again. Visitors experience repeated disorientation, as if the mountain is shifting position while remaining still. Mount Fanjing's isolation is not only visual, it is ecological. The protected area surrounding the summit spans more than 219 square miles and shelters ancient ecosystems rarely disturbed by modern development. High humidity, frequent fog, and stable temperatures support rare plant and animal species that evolved under long-term isolation. The mountain functions as a biological archive, preserving lineages that disappeared elsewhere. Cultural meaning deepens this separation. For centuries, Mount Fanjing has been regarded as a sacred site, associated with Maitreya, the future Buddha. Pilgrims approach not as explorers, but as visitors, entering a space governed by restraint. Silence is encouraged. Movement slows, naturally. The physical challenge of ascent, long stairways cut into steep slopes, acts as a filter, reducing numbers and preparing the body for stillness. Even with these paths, access remains conditional. Weather determines visibility, Wind dictates comfort. Clouds decide what may be seen. The mountain allows no control over experience. One may arrive expecting a view and find only whiteness. Another may witness the pillars emerge briefly before vanishing again. There is no guarantee of revelation. Sound at the summit is minimal. Wind brushes against stone. Footsteps echo sharply, then disappear into fog. Voices feel intrusive. The environment encourages observation without interaction, reinforcing the sense that this is not a place to occupy, but a place to pass through lightly. Within the structure of this journey, Mount Fanjing marks the point where boundaries become explicit. The landscape no longer merely limits human comfort, it imposes conditions. Access exists, but permission is temporary and fragile. Presence depends on weather, endurance, and restraint. Here, the Earth begins to withdraw clarity. Scale dissolves, orientation fails. The mountain reveals itself only in fragments, reminding the observer that some places do not exist to be fully seen. Mount Fanjing stands not as a destination, but as a threshold where solid stone teaches impermanence, and where the sky decides how much of the world is allowed to appear. Socotra does not feel like an island. It feels like a biological detour, an environment that's separated from the rest of Earth long enough to rewrite its own rules. Located in the Arabian Sea, roughly 150 miles east of the Horn of Africa, Socotra has remained isolated for more than 20 million years. That separation is not just geographic, it is evolutionary. Nearly everything here looks unfamiliar. More than 300 plant species found on the island exist nowhere else on the planet. And close to 90% of its reptiles are endemic. Shapes, structures, and growth patterns diverge sharply from continental logic. Walking across Socotra feels less like travel and more like observation, like entering a natural laboratory where evolution was allowed to proceed without interruption. The island's most iconic form is the dragon's blood tree. With its thick trunk and wide, disc-shaped crown, it resembles an umbrella frozen mid-expansion. This shape is not decorative. It is functional. The dense canopy captures moisture from fog and reduces evaporation beneath, allowing the tree to survive in extreme aridity. The red resin within its bark, once used for medicine, dye, and ritual, adds to the impression that the tree belongs to a different era or a different world. Socotra's terrain reinforces this sense of otherness. Limestone plateaus, sharp granite peaks, and dry coastal plains coexist within short distances. Rainfall is scarce and unpredictable. Strong monsoon winds isolate the island for months at a time, cutting it off from regular access. These conditions shaped survival strategies that favor resilience over speed, longevity over growth. Animals here reflect the same pattern. Many species retain ancient genetic traits lost elsewhere due to competition or environmental change. Forms are often simpler, slower, and highly specialized. Evolution on Socotra did not accelerate. It refined. Without predators or invasive pressure for millions of years, life followed paths rarely preserved on modern Earth. Human presence has always been limited. Historically, Socotra was a waypoint, rather than a destination, visited briefly by traders and sailors, then left behind. Permanent settlement remained sparse, and traditional lifestyles adapted closely to the island's constraints. Modern access is still restricted by geography, weather, and conservation policy. Tourism exists, but it is fragile and carefully managed. There is no infrastructure designed for scale. This restraint is essential. Socotra's ecosystems are not resilient to disruption. The same isolation that allowed unique species to evolve also makes them vulnerable. Introduced plants, animals, or intensive development could unravel systems that took millions of years to stabilize. Preservation here is not an abstract goal, it is a necessity. Visually, the island challenges familiarity. Trees grow at odd angles. Rock formations appear unfinished. Landscapes lack symmetry. The eye searches for patterns it recognizes and fails. This dissonance creates a subtle unease, followed by fascination. The mind realizes it is encountering outcomes shaped by time spans far longer than human history. Within the progression of this journey, Socotra represents a decisive boundary. This is no longer a place defined primarily by geology or climate, but by deep biological independence. The island does not resist humans through danger or inaccessibility alone. It resists through fragility. Presence here must be light, temporary, and respectful. Socotra stands as evidence that Earth does not evolve toward familiarity. Given enough time without interference, it produces worlds that feel alien, even to those who live on the same planet. This is not an island waiting to be discovered. It is a reminder of what the Earth becomes when left alone long enough to forget us entirely. Mount Popa rises abruptly from the central plains of Myanmar, a solitary volcanic mass standing nearly 5,000 feet above sea level, detached from surrounding terrain like an exposed core of the Earth. Unlike mountain ranges that emerge through compression or collision, Popa exists alone. Its isolation is immediate and unmistakable. Flat agricultural land stretches outward in all directions until the volcano interrupts the horizon with a steep, dark silhouette. Geologically, Mount Popa is the remnant of an ancient stratovolcano formed more than 250,000 years ago. Eruptive phases built layers of basalt, ash, and hardened magma, while later erosion stripped away weaker material. What remains today is a solid volcanic spine, dense, fractured, and highly porous. This structure allows the mountain to function as a natural reservoir. Rainwater seeps deep into the rock, and is stored underground, slowly released through springs that support surrounding communities in an otherwise dry region. The mountain's height and isolated position create localized climate effects. Air rising along the slopes cools rapidly, producing clouds that often wrap tightly around the summit, while the plains below remain clear and hot. From a distance, the peak appears to float, its base visible while its crown dissolves into mist. The contrast reinforces the sense that Mount Popa occupies a different atmospheric layer from the land around it. Built directly into the volcanic cliffs is the Taung Kalat Monastery Complex, one of Myanmar's most important pilgrimage sites. The structures do not sit atop the mountain, they cling to it. Temples, stairways, and shrines are anchored into near-vertical rock faces, following the contours imposed by geology rather than overriding them. The architecture adapts completely to the terrain, creating the impression that the religious space grew out of the stone rather than being placed upon it. Reaching the summit requires ascending hundreds of steps exposed to heat, wind, and height. The climb is physically demanding, and intentionally so. Effort acts as a filter. As elevation increases, movement slows, conversation fades, and attention narrows. By the time visitors arrive at the upper platforms, the body has already adjusted to restraint. The mountain enforces preparation before granting proximity. Mount Popa's spiritual significance is inseparable from its geology. In local belief, the mountain is home to powerful Nat's guardian spirits tied to natural forces and ancestral memory. These entities are not abstract. They are bound to the rock itself. The volcano is not merely a backdrop for worship. It is an active participant. Offerings, rituals, and silence acknowledge the presence of something older and less negotiable than human intention. Despite the steady flow of pilgrims, Mount Popa does not feel crowded. Space is segmented by cliffs and elevation. Sound dissipates quickly. Wind carries prayer bells and footsteps away from their source. The environment absorbs human presence without yielding to it. Even at its most active, the mountain maintains authority. Within the structure of this journey, Mount Popa represents a boundary where geology and belief converge. Access is possible, but governed by reverence rather than curiosity. The landscape does not invite exploration. It demands alignment. Visitors adjust behavior instinctively, lowering voices, slowing pace, and respecting limits set not by signs, but by stone. Here, the earth does not exclude humans, it conditions them. Mount Popa stands as a reminder that some environments are not meant to be understood through observation alone. They are approached through humility, where the boundary between land and meaning becomes indistinguishable, and where the mountain decides how close one is allowed to come. The Danakil Depression lies in northern Ethiopia as one of the most extreme environments on the planet, a place where the earth appears unfinished, exposed, and actively releasing energy. Sitting more than 400 feet below sea level, the region occupies a tectonic junction where three continental plates slowly pull apart. Here, the crust is thin. Heat rises close to the surface. The planet does not hide its internal processes. The ground in Danakil is a mosaic of salt flats, sulfur fields, acid pools, and fractured rock. Colors dominate the scene: intense yellows, greens, whites, and rust reds, produced by sulfur, iron oxides, and chloride minerals. These hues are not decorative. They are chemical signals, marking zones where geothermal gases and fluids reach the surface. The land looks painted, but it is constantly changing. Temperature defines every movement. Daytime heat regularly exceeds 110 degrees Fahrenheit, while ground temperatures near active vents climb far higher. In some areas, thin crust overlays boiling fluids only a few feet below. The surface may appear solid, yet it can shift or collapse without warning. Walking here is not navigation, it is negotiation. Gases escape continuously from cracks and vents. Hydrogen sulfide fills the air with a sharp odor of rotten eggs lingering low to the ground. Carbon dioxide collects in shallow basins, displacing oxygen and creating invisible hazards. These emissions are not episodic, they are constant. Danakil does not erupt in moments, it exhales. Salt dominates much of the depression. Ancient seas once flooded the basin, and as water evaporated, thick layers of salt were left behind. Over time, tectonic movement fractured these deposits into plates and ridges, forming a blinding white landscape that reflects sunlight intensely. In places, salt is harvested by hand, cut into blocks, and transported across the desert, a reminder that human survival here depends on direct adaptation rather than comfort. Sound behaves unusually in this environment. Wind is minimal, but the land itself produces noise. Hissing gas, bubbling mud, faint cracking beneath the surface. Silence feels unstable. The ground seems active, even when nothing moves. At night, heat radiates upward, and the horizon glows faintly under reflected light, erasing darkness. Despite the hostility, life persists at the margins. Microorganisms thrive in acidic pools and superheated water, surviving conditions lethal to most organisms. Their presence demonstrates that biological limits extend beyond human tolerance. Danakil is not lifeless, it is selectively alive. Human presence here is brief and controlled. Travel requires escorts, water planning, and precise timing. There is no shade, no recovery space, exposure accumulates quickly, and mistakes compound. The environment offers no margin for error. It does not forgive. Within the progression of this journey, Danakil represents a decisive shift. This is no longer a place that restricts access symbolically or culturally. It does so physically. The boundary is enforced by heat, chemistry, and geology operating in real time. Danakil depression is often described as otherworldly, but that description is incomplete. It is not another planet, it is this one stripped of buffering systems, revealing processes normally hidden beneath continents and oceans. Here, the Earth does not wait. It releases pressure, it vents, it breathes, and in doing so, it makes clear that human presence is temporary, conditional, and secondary to forces still shaping the planet from within. El Tatillo lies high in the Atacama region of northern Chile, spread across a broad plateau at an elevation of approximately 14,170 feet. At this height, air pressure drops, temperatures fluctuate sharply, and the ground retains little heat overnight. It is within this thin, cold atmosphere that one of the world's largest geothermal fields operates in full view, releasing heat into an environment defined by freezing air. The field covers more than 11 square miles and contains over 80 active geysers, accounting for nearly 8% of all known geysers on Earth. Their activity follows a precise rhythm governed by pressure and temperature. During the night, water accumulates underground. As dawn approaches and surface temperatures remain near freezing, steam pressure builds rapidly. At first light, jets of boiling water burst upward, sending columns of vapor several hundred feet into the air. This contrast defines El Tatillo. Superheated water meets air cold enough to instantly condense steam into thick white plumes. The geysers appear more powerful than they are because the cold atmosphere amplifies visibility. Each eruption becomes a vertical structure, briefly solid in form, before dissolving into the sky. Light from the rising sun catches these plumes, turning the plateau into a shifting landscape of glowing columns. The ground beneath the field is fragile. Thin mineral crusts form around vents and pools, concealing scalding water below. Stepping off established paths risks breaking through into boiling channels. Despite the apparent openness of the terrain, movement is tightly constrained. The plateau allows passage only along narrow corridors of safety defined by experience rather than markers. Sound is muted by altitude. Boiling water roars close to the vents, but the vastness of the plateau absorbs noise quickly. The dominant sensation is not loudness, but exposure. Cold air bites at skin, while heat radiates upward from the ground. The body struggles to reconcile opposing signals. Breathing becomes deliberate, motion slows. The water here is rich in dissolved minerals, coating rocks in white, yellow, and orange deposits. Over time, these layers build terraces and ridges that channel flow into repeating patterns. Unlike violent volcanic environments, El Tatio's energy release is measured and continuous. The system does not erupt in catastrophe. It vents steadily, maintaining balance between pressure and release. Human presence is temporary by necessity. The altitude induces fatigue and disorientation. The cold limits duration. Most visitors arrive before sunrise and depart as temperatures rise and geyser activity diminishes. By late morning, the plateau empties. Steam thins. The field returns to relative stillness, awaiting the next cycle. Within the logic of this journey, El Tatio marks a critical contrast to the previous environment. Where Danakil overwhelms through heat and chemistry, El Tatio challenges through opposition, freezing air, restraining boiling water. The boundary here is not danger alone, but physiological stress. The body must adapt to survive even brief exposure. El Tatio demonstrates that extremity does not require violence. It can exist in balance, sustained over millennia by precise physical conditions. The geysers do not perform for observers. They follow thermodynamic law. On this frozen plateau, the Earth reveals a controlled release of internal heat, visible, repeatable, and indifferent to presence. The geysers rise, collapse, and rise again, reminding the observer that even at the edge of human tolerance, the planet continues its cycles without pause. Safaranga Cold Desert stretches across the highlands of northern Pakistan as a landscape defined by contradiction. Sand dominates the ground, yet heat does not. At an elevation of roughly 7,500 feet above sea level, the desert exists in a climatic zone where air is thin, moisture is scarce, and temperature drops sharply as soon as the sun begins to fall. This is not a desert of burning horizons, but one of cold air, sharp light, and silence. The sand here carries a distinctive pale, almost metallic tone. Rich in silica and low in organic material, the grains reflect sunlight strongly, giving the surface a silver sheen that remains consistent across seasons. Unlike warmer deserts, where wind constantly reshapes dunes into dramatic crests, Safaranga's forms change slowly. The cold stabilizes movement. Wind still passes through, but erosion happens with restraint, carving subtle ripples rather than violent shifts. Daylight brings clarity. The sky appears unusually wide, unbroken by vegetation or vertical features. Distance becomes difficult to judge. Objects seem closer than they are. At night, the transformation is immediate. Temperatures fall rapidly, sometimes by tens of degrees, and the desert contracts into stillness. Sound disappears almost completely. Even wind feels muted, as if absorbed by the sand and air together. This silence is one of Safaranga's defining features. There are no insects, no flowing water, no persistent mechanical noise. The environment strips away background sound until only the most direct sensations remain. Footsteps pressing into sand, breath in cold air, fabric moving against the body. The desert does not overwhelm the senses, it reduces them. Historically, Safaranga has served as a testing ground for endurance rather than a corridor for trade. Expeditions crossing the region recorded long exposure to wind chill, dehydration, and disorientation despite the absence of extreme heat. The challenge here is not survival against intensity, but against monotony and isolation. The landscape offers few reference points. Navigation depends on awareness rather than landmarks. The desert's cold nature shapes perception of time. Without visible motion or environmental cues, minutes feel extended. The body remains alert, waiting for change that rarely comes. This psychological effect is subtle but persistent. The environment encourages introspection by removing distraction. There is nothing to respond to except the self. Local stories describe the wind of Safaranga as carrying memory, an expression of how sound travels long distances across open ground and returns faintly altered. These narratives do not frame the desert as hostile, but as contemplative. It is a place associated with reflection rather than danger, endurance rather than conquest. Human presence here is sparse and temporary. There are no permanent structures, no infrastructure to anchor activity. Movement through the desert leaves minimal trace, quickly erased by light, wind, and settling sand. The landscape absorbs passage without acknowledgement. Within the progression of this journey, Safaranga represents a quieter form of extremity. After environments that confront the body with heat, chemistry, or pressure, this desert introduces deprivation. It removes stimulation rather than adding threat. The boundary is psychological as much as physical. Safaranga Cold Desert shows that isolation does not always announce itself with drama. Sometimes it arrives through stillness, through repetition, through the absence of change. The silver surface reflects light, but nothing else returns. Here, the earth does not challenge the body to endure force. It challenges the mind to remain present in a place where almost nothing happens and where that nothingness becomes the defining experience. The Arctic ice cap stretches beyond conventional geography, presenting itself not as a place, but as a boundary made visible. From the edge, the ice rises in vast white walls, sheer faces of compressed snow and ancient frost extending to the horizon. There is no gradual transition. Land ends and ice begins, forming a stark division between the solid Earth and a frozen system that operates on planetary time. This ice did not form quickly. Over hundreds of thousands of years, snowfall accumulated layer by layer, compacting under its own weight into dense ice, more than 2,600 feet thick in places. Each layer sealed fragments of atmosphere inside microscopic bubbles, preserving air from eras long before human presence. These frozen records turn the ice cap into a climatic archive, a vertical timeline storing tens of thousands of years of atmospheric history. Visually, the ice appears uniform at first glance, but closer observation reveals motion. Long fractures stretch for miles across the surface, forming jagged lines that slowly widen and shift. Massive ice waves ripple outward, evidence of constant internal movement driven by gravity and temperature gradients. The ice cap is not static. It flows imperceptibly slow, yet unstoppable. At the margins, towering ice cliffs rise 60 to 90 feet above the frozen sea. When sections collapse, the sound travels across the open expanse like distant thunder. The echoes linger, unbroken by trees or terrain, reinforcing the sense of scale. Even sound behaves differently here. It moves farther, thinner, less obstructed. Standing before this wall produces a sensation unlike other landscapes in this journey. There is no complexity of form, no color variation beyond white, blue, and shadow. The eye finds no detail to hold. Depth becomes difficult to judge. Distance loses meaning. Orientation weakens. The environment reduces perception to essentials: cold, light, and silence. Beneath the surface lies immense stored water. If released entirely, it would raise global sea levels by several inches. This potential is invisible, locked within solid mass. The ice cap embodies suspended consequence, a structure whose stability affects coastlines thousands of miles away, despite remaining physically untouched by most of humanity. Access to this environment is limited not by law, but by practicality. Extreme cold, isolation, and logistical complexity restrict human presence to brief scientific missions. There are no settlements, no sustained activity. Equipment fails quickly. Exposure accumulates without mercy. The ice does not accommodate error. Despite its hostility, the ice cap supports specialized life. Microorganisms exist within brine channels inside the ice, surviving in darkness and pressure. Their presence demonstrates that life adapts even here, but on terms completely separate from human biology. Survival follows rules dictated by physics and chemistry, not comfort. Within the structure of this journey, the Arctic ice cap marks a transition from hostile environments to fundamentally non-human systems. Heat, wind, and altitude have tested the body in previous landscapes. Here, the body becomes almost irrelevant. The ice operates on scales that ignore presence entirely. This is not a place to explore. It is a structure to witness briefly from the edge. The ice does not invite, approach, or interaction. It offers no paths, no shelter, no reward for effort. It exists as a wall, a limit, and a reminder. At this boundary, the Earth no longer reacts to humans at all. It continues its slow compression, its silent flow, its preservation of time, unaware, unmoved, and absolute. Xiaojia Tiankeng opens without warning in the karst landscape of Chongqing, a vast vertical void where the surface simply gives way. From the rim, the ground drops more than 2,100 feet straight down into darkness, forming the deepest known sinkhole on Earth. Its mouth spans nearly 2,000 feet across, wide enough to swallow entire city blocks, yet the opening feels precise, like a deliberate incision rather than a collapse. The structure formed within limestone, more than 150 million years old. Over geological time, slightly acidic rainwater seeped into fractures, dissolving calcium carbonate and enlarging underground chambers. What makes Xiaojia exceptional is scale. Instead of a gradual subsidence, a massive cavern system expanded until the roof could no longer support itself. When it failed, the surface did not crater. It vanished, exposing a vertical corridor between worlds. Standing at the edge produces an immediate distortion of perception. Depth overwhelms horizontal reference. Sound drops away. Wind behaves unpredictably, drawn downward into the void. The eye struggles to fix on a bottom that appears distant yet clearly defined. The space feels less like a hole and more like a passage, an opening that leads somewhere the surface does not belong. Inside, the environment changes completely. Humidity approaches 100%, trapping moisture and heat within the sinkhole walls. Sunlight reaches the floor only indirectly, filtered by sheer rock and drifting mist. As a result, a self-contained ecosystem thrives below. Ferns, mosses, and moisture-loving plants coat the walls, while trees at the base rise to heights of more than 130 feet, competing upward toward light that rarely arrives. This vegetation does not mirror the forest above. It follows a separate rhythm, governed by shade, condensation, and still air. The sinkhole functions as a vertical island, isolated not by water, but by rock and gravity. Species here exist in a protected microclimate, shielded from surface winds, temperature extremes, and human disturbance. Movement within Xiaozhai is limited and deliberate. Descending requires specialized equipment and controlled routes. The walls are steep, fractured, and unstable in places. Loose rock falls regularly, accelerated by moisture and erosion. The space does not allow casual exploration. Every step is negotiated with gravity. Sound behaves unusually inside the chasm. Noise from the surface fades quickly, replaced by echoes that stretch and distort. A single voice can rebound multiple times before disappearing. Water dripping from unseen ledges creates a constant, distant rhythm, reinforcing the sense that the sinkhole is active even when still. Human presence here is rare and temporary. Scientific teams enter to study karst systems, hydrology, and isolated ecosystems, but prolonged occupation is impossible. Light, communication, and orientation all depend on technology. Without it, the environment quickly becomes disorienting. The sinkhole does not provide cues designed for surface navigation. Within the progression of this journey, Xiaozhai Tiankeng represents a decisive break from surface landscapes. Previous environments limited access through climate or exposure. Here, access is restricted by dimension. The boundary is vertical. The Earth does not stretch outward, it opens downward. Xiaozhai is not a space to inhabit. It is a threshold revealing the planet's internal architecture, usually hidden beneath layers of soil and time. Looking into it feels less like observation and more like witnessing a structural truth. This is where the surface world ends, not gradually, but absolutely, and where the Earth reminds the observer that beneath familiar ground lies a depth that does not acknowledge human scale. Blue Lake, known locally as one of the deepest karst lakes in the Caucasus, presents itself not through scale of surface, but through depth concealed beneath stillness. From above, it appears calm and compact, a dark blue circle set into the surrounding landscape, with no visible inlets or outlets. There are no streams feeding it, no rivers carrying water away, yet beneath this quiet surface lies a vertical system that descends far beyond ordinary perception. Modern surveys have confirmed a measured depth of approximately 863 feet, making it one of the deepest known karst lakes on Earth. Even this figure is incomplete. Divers descending into the lake report that the bottom continues to widen into a dark funnel, suggesting that the true depth extends beyond current exploration limits. The lake does not end cleanly. It opens Blue Lake is fed entirely by underground pressure. Water circulates through deep karst channels carved into limestone over millions of years, rising from below rather than flowing in from the surface. This closed circulation system creates unusual stability. The water level remains nearly constant year-round, unaffected by rainfall or seasonal change. What moves here is not surface water, but pressure. The lake's defining feature is its color. The water appears an intense, ink-like blue that absorbs light rather than reflecting it. Sulfur compounds dissolved in the water contribute to this effect, along with extreme clarity. Light penetrates only so far before being swallowed by depth, giving the lake a visual quality closer to a void than a pool. Standing at the edge, the eye senses absence rather than volume. A faint sulfur smell lingers constantly in the air. It is not overwhelming, but persistent enough to remind visitors that the water is chemically active. This subtle warning reinforces the lake's reputation in local tradition. Sharp objects are discouraged near the surface, and disturbance of the water is considered disrespectful. According to regional belief, The lake connects to hidden chambers deep within the mountain, places where stability depends on balance. Sound behaves differently here. There is no current noise, no visible movement. Even wind seems to lose urgency near the shore. Voices carry briefly, then fade. The stillness feels deliberate, as if the lake absorbs more than light. It absorbs motion. In 2018, a technical diver descended to a depth of roughly 656 feet, reaching the limit of safe exploration. Below that point, visibility narrowed into darkness, and the passage continued downward beyond reach. The attempt confirmed what the surface suggests. Blue Lake is not designed to be fully known. It resists completion. Despite its depth, life exists within the lake, but only in specialized forms adapted to low light and high mineral content. These organisms do not occupy the depths uniformly. They cluster where chemistry allows, reinforcing the idea that the lake is structured vertically, not horizontally. Human interaction with Blue Lake remains cautious. There is no recreational use, no swimming routes, no platforms extending over the water. Observation happens from the edge. Presence remains external. The lake does not accommodate entry. Within the structure of this journey, Blue Lake represents the final withdrawal of accessibility. Earlier environments restricted approach through heat, altitude, or exposure. Here, restriction comes from opacity. The boundary is not enforced by danger alone, but by unknowability. Blue Lake does not confront the observer. It waits. It offers a surface that appears simple and conceals a depth that refuses resolution. In doing so, it marks a point where exploration gives way to acknowledgement. This is not a place that invites dissent. It stands as a reminder that some parts of the Earth are not hidden. They are simply deeper than we are meant to follow. This journey does not end with a final location. It ends with a pattern. Across continents and climates, each place revealed a consistent logic. The world does not divide itself by beauty or danger, but by permission. Some landscapes allow human presence briefly, others tolerate it conditionally, and some operate entirely beyond human relevance. What changes from place to place is not wonder, but access. At the beginning, the earth still accommodates approach. Stone curves into form, water settles into balance, collapse can even be repaired. But as the journey progresses, tolerance narrows, distance stretches, wind erases comfort, altitude taxes the body, heat and chemistry impose strict limits. Finally, the planet withdraws altogether into ice that records time, into vertical voids, into depths that cannot be reached or fully known. This is the structure of the impossible world. It is not a collection of extremes, it is a gradient of separation. What unites these places is independence. Each operates according to its own internal rules, geological, biological, or climatic, without adjustment for observers. Their value does not increase with attention. Their meaning does not depend on visitation. In many cases, preservation exists precisely because intrusion remains difficult, limited, or unwelcome. These environments challenge a familiar idea of exploration. They are not puzzles to be solved or destinations to be consumed. They do not reward conquest. They offer no resolution. Instead, they define boundaries, points where human systems stop applying and planetary systems continue without interruption. The lesson is quiet but firm. The Earth is not entirely accessible, and it does not need to be. Some places function best when left intact, unseen, or only briefly witnessed. Their role is not to host us, but to remind us that we exist within a much larger framework, one governed by timescales, forces, and processes that do not respond to intention. Impossible World is not about places that cannot be reached. It is about places that should not be reduced. These landscapes are not destinations. They are limits. And standing at those limits, the only appropriate response is not possession, but recognition, followed by restraint.